talking about today. I'll just give you a little bit of background about me and how I came into security. I'm going to talk about a project I worked on for the DevRel Foundation. That's just sort of the context in which I made some observations, tried a few things out. How many people have used Svelte or have teams that have used Svelte? Well, great. I'm going to tell you just a little bit about it. It's a web framework, just to get a little bit of a sense of what this project was about. I then went and, because of various reasons, wanted to experiment and learn. That's going to be one of the key messages I've mentioned here about open source as opportunities for learning. And so I wanted to learn a little bit more about generating code, what that looked like, and how that workflow worked. So I'm going to talk about that. We did, the OWASP top 10. I have a few notes about that and how I used those resources in order to try to look at the application I was building. And then all of this sort of coincided with a lot of these supply chain incidents. So I'm going to talk about a few of the more interesting ones and what ultimately led me to finding out about my application. So that's my plan for today. As was mentioned in the introduction, I lead security advocacy for Semgrep, but in a separate role, I'm also on the steering committee for this DevRel Foundation. And so my career is maybe a little atypical in some ways. A lot of roles I found myself to be in very cross-functional positions, sort of this Venn diagram between engineering, marketing, product, and sales. I've also worked for a lot of organizations. I won't talk about too many of them in the talk, but if you want to come ask me questions about some of them afterwards, I can share. So like at Dolby, I was at Capitol Records Tower in a studio with Vince Staples, and you'll never believe what his entourage did. When I was working for GE, I was doing tech support or supporting a hackathon, and it was a hackathon we were trying to do on a boat in Berlin, of all places, and the CEO made a surprise announcement that day. I also work for DreamWorks, so this is where I mentioned 19 feature film credits. I was a production engineer for DreamWorks and worked on a lot of films, including, I think it was mentioned, Megamind. So one little fun fact, we had 3 different names for that movie ahead of time, and the voice cast was entirely different the first time I saw it. You'll have to ask me about that later. Here does geospatial. So I also worked in the geospatial industry around highly automated driving, and of course, self-driving cars, a lot of security considerations there and how to use navigation systems. I also worked for the MathWorks. So if you've ever used MATLAB, I was part of the build and test team that did security, build systems and everything. And funnily enough, tested MATLAB with MATLAB. And then Rackspace is another company I worked for doing cloud computing. I do this thing now called developer relations or advocacy. It actually started when I was at Rackspace because I developed iStream and Weird Al Yankovic spit on me. So I can explain more about that later. But a lot of these companies have also had open source programs. And so I think that's where everything from working in open cloud environments to IoT systems to some of the work I'm doing now with the DevRel Foundation, which is part of the Linux Foundation. So about that, I'm not going to go too much detail. This just gives a little bit of context. So it was a Linux Foundation collaboration project, which means the deliverables is not software in the sense, right? Like it's not building a new open source dependency that someone would download and use. It's more, there's a number of projects within the Linux Foundation that focus on process, similar to some of the things you might see with OWASP in the sense of like if you're running open source programs, here are some best practices for how to organize if you're trying to adopt or guide people on how to engage with open source and contribute others' guidelines. So similarly, for the function of developer relations is a foundation that's really built around the idea of, hey, can we gather some best practices and provide resources that help educate people on what it is. And what it is really this practice of nurturing and building relationships with communities. And so that takes a lot of different forms like community engagement, providing technical support and answers to questions when people struggle with something. But fundamentally, it is about technology adoption and explaining what is a technology, why is it important, and how do you go about using it. And so last summer, August 25th, was the Open Source Summit in Europe. And there was a plan to announce the formation of the DevRel Foundation. It was in this incubation stage for a while. And it was going to be this big announcement. So we had one problem. in July 2nd, it was sort of realized, well, what are we going to tell people to go look at? We don't have a website. And so that was 7 weeks before the announcement, but we wanted that website not just to be a little splash page or CMS. It should be something engaging that talks about all of the projects that we're working on and all the things that we're building. And so that was sort of the foundation of which got me into this project. So Svelte is a UI framework. So it uses a compiler to write components. So similar to the ecosystems of React or Next, Vue, that it is a component-based system, but it has a few unique characteristics. SvelteKit runs the server side. It's gaining some traction. Apple's recently done their app store using Svelte. Spotify, New York Times, or other ones that have sort of given this belief that it is production ready. And that had been one of the concerns where people were using React a lot, Next a lot as kind of their default, but Svelte was becoming a nice alternative. And there's a couple of reasons why that's nice. One, the creator of Svelte, Rich Harris, works for Purcell, makes it really easy to deploy. It's fast in terms of implementation and performance in some of the reactive components because it's done as a pre-rendered server-side build step. So it sort of changes the workflow compared to some other web applications that are out there. And the components are really defined in a very concise way so that if web application development foundationally, HTML, JavaScript, and CSS, and it feels much more like working with those than an abstraction above it. And so for some of those reasons, it's been gaining a fair amount of popularity. And so then it becomes a question of, how many systems are out there? I didn't see anyone raise their hands encountering it at this point. But in the Stack Overflow survey last year, 9th on the list of desired frameworks for use, and a 3rd on the list of admired. So it's the people who are using it are demonstrating that there's a satisfaction that comes from using it, but also that it is growing in usage. And I think Apple, New York Times, and are good examples of that happening. And so just to give an idea of what this looks like, because I think it's a little bit relevant, there is a Svelte playground and interactive tutorials. It makes it really easy to go and experiment, but foundationally, you have an application, you import other components, those components might import other components. So there is a nesting, there is a data flow as you go through those components. So they haven't necessarily invented a new JSX or something like that, similar to the React ecosystem, but there is this element of properties that are coming from user input. And then the style was all there. And so through these compilation steps, it's actually taking a lot of this and generating other web code. So from an analysis point of view, even if you're looking at a Svelte application, it's not necessarily the thing that's going to be running at the end. And so I think that's an important characteristic. So in terms of building this application, so I already mentioned I had a little bit of a tight deadline. It is also the case that this is open source. It's volunteers. I had a day job. Everyone else that was involved had a day job. So we're really getting sporadic contributions from lots of people at different times. And so this became suddenly, is this a good opportunity to experiment with generating code and using LLMs? And so thinking about the requirements for this project a little bit, it also gives it a sense of what types of problems we might run into. So there are a lot of static pages. So fundamentally implementing Svelte components and a lot of web projects like this, you might have hundreds of these, and each of those might be something that someone would have to go in and look at from a scaling perspective. Also in October of 2024, there was a new release of Svelte. And so it changed a few of the patterns around data flow and interactivity. And so as a result of that, it's actually better to use the newest version and try to change some of the patterns that people had implemented prior, even though there was backward compatibility support. And of course, the deployment pipeline. So there are lots of CMSs. We could go out and use Medium and some other hosted blogging platform, but we wanted to have one associated with the foundation directly. We could go off and just to use another Squarespace or some other hosted web application to build a bunch of pages. But again, we wanted it to be an integrated thing, as well as some additional dynamic content. So if you've used static site builders, or if you know teams that have used static site builders, a lot of times somebody will write instructions in Markdown, then you're gonna render it out, right? So Gatsby, there's a whole bunch. I'm not gonna list all of them, but we wanted that same sort of behavior. And since we were using, an LLM, try to generate some of the code, it was like, well, maybe we can build in some of that behavior ourselves instead of bringing in some third-party dependency. One other element of this is reading in JSON data. So some of the projects within this foundation were really designed around coding open data, or providing open data as JSON. So some of the projects involve like events, personas, or tools, and really ways of describing those tools that are separate from the database. And so the application is supposed to read and display that information, which means it has to go off and contact some data point. There are some third-party services. So like a lot of groups, right? We were talking about Meetup before. You might have a bunch of events. And if you're not using a third-party platform, but you want to have that, there might be a service that provides the scheduling. And so the Linux Foundation similarly has some services around using Zoom for conferencing, or using another platform that tracks the events, but it doesn't necessarily surface those events on the website. So you have to build sort of that glue and that integration. And then there are, of course, things like dark mode, GDPR cookies, things like that. And then, of course, there are some things that might come up as typical security concerns. So in this case, we didn't really have user authentication requirements. We're really only reading data. So the website's not going to be used for storing user input. So there's not a whole lot of opportunities for someone to do something too malicious, but there are a few places like subscribing for a newsletter, or doing a search, or pulling up some of the data. So I'm not going to go too deep into that, but start talking about the workflow that got us there. So if I'm thinking about the software development lifecycle, right? So plan, code, build, test, deploy, operate. Not too surprising, but for such a small project, if shift left is faster, cheaper, more secure, we want to do more testing earlier in the process, to understand if there's going to be any security concerns, because it's not like we have a dedicated security person. It's an open source project. It does mean that the code is available for anyone to look at, and that presumably there would be a disclosure process if something was found that was problematic. So again, AI can do this, right? So we're going to speed up our development time. Not sure exactly what's going to go, but whether the code comes from my brain or somebody else's GPU, it still ships. So if I go back to the rest of the process, presumably code, that code step, maybe I'm generating code in various ways, but I still need to go through the build process. I still want to test it, deploy it, and be able to have the rest of the pipeline look the same. We're really just talking about this code generation part that we're shifting a little bit differently. So what are some of the things that went well? So I had been reading a book by Adi Azamani called Beyond Vibe Coding, From Coder to AI Era Developer. Has anyone read that one by any chance? Sort of talks about, sort of this transition from vibe coding to more mature development processes using AI. So during the course of this project, I found that I did 540 prompts. So I had a log of everything I did, including all of the prompts. And so I was just kind of curious, like, how long did it take us to get all of the functionality of this website? So we talked about the requirements, and the website is public right now, so you could go to devrel.org. It's linked off of the Linux Foundation and everything, and sort of see that it has a live blog, it has some static pages, it also has some projects. So that allows you to filter, sort, and look for various things. So it's not that atypical from maybe a more complex web application. But the way a lot of these prompts occurred was through a little bit more of a programming design and iteration. So what that means is I had, some of the requirements, tried to flush out what those requirements are, characteristics I wanted to see. And then I would generate some code, and then I would go and look at it, review it, poke at it, try the different behaviors, see what would work or not. This project started, I said last summer, but I was still kind of using GitHub Copilot, even though there were alternatives, Cursor, as well as Cloud Code. But for this project, it was, a side project. It was something that a lot of people in the open source group had access to, so that we would use a similar tool. It was also during the course of these prompts, there was a lot of switching between different models. So I wouldn't say that everything was generated with Gemini. We tried that out and a couple of the features that were being added. We used Sonnet for a lot of the features that were being added, experimented with Grok for some of the features that were being added. And each one was sort of an opportunity to try something out, generate it, take a look at it, and then do an inspection of it and see like, hey, did this work the way it was supposed to from a functionality point of view? And do I trust that this code looks legitimate, or do I have to edit it? And in many cases, there was a fair amount of editing. So it might give a very nice scaffolding for starting a project. Then it was a little bit of modification and tweaking, and then using another prompt to review it or make some adjustments. Some of the prompts were even very complex, like sending a full design with it. So some of the successes. So a couple years back, I did a sentiment analysis project on Reddit communities. So I actually went and got the Python Reddit community and wrote some code to actually gather all this up. This was sort of in that deep learning phase of tech, so maybe about 8 or 9 years ago. And just to see what is a positive sentiment, a negative sentiment, that kind of thing. So dusting off a few of those tools, took a look at this, and based on my reaction to some of the prompts, because it does feel like a chatbot, like you're interacting in some cases and be like, no, that's wrong. Undo all of that, which would very clearly express a negative sentiment about what code was generated because something was bad. Or in some cases, approximately 15 times, it actually generated something. I looked at it and I was pretty happy with the result, and then committed the change and then moved on. So in some cases that happened very well. And the cases that worked really well were introducing constraints. So don't do X, only focus on Y, or putting in a reminder like, hey, make sure that the user input is checked and validated any place within the application, or only apply this type of rendering to headings for one reason or another. And so by being very clear on what some of those constraints, i.e. having better requirements written out to begin with, really helped me get closer to the result I was looking for. And then UI, UX intent was important. So in one case, I looked at another application I was interested in, took a picture of it and said, hey, let's do something similar to this, and annotated it a little bit. I was able to interpret that and grab code from other websites and sort of say like, hey, modify this. I like where this is going, but I wanted to do X, Y, and Z instead, and really customize the type of thing that I was seeing as a result. But there were lots of failures. So a lot of the prompts, around 150 of them, resulted in imperfect results. I'm not going to share those logs because I was probably rather unkind in some of my reactions.
You'd be like Skynet come and kill you.
Yeah, yes. And again, because it was felt like this informal development environment or conversation that I was having with the tool. So sometimes changes were made to parts of the code that I didn't expect. So the layout might change in one part of the application rather than the part I was trying to focus on because I didn't set up sufficient constraints. Or I didn't give it guardrails around, hey, this is what I expect to happen. And I want you to only change this other thing. And so what that really resulted in was sometimes there were very compound requests that resulted in regressions. So even if I thought I fixed a flaw in how something behaved, it might come back again. In some cases, even if I thought I fixed a case where I was concerned about user input not being validated, well, it might actually copy the code from somewhere else and modify it and remove those checks. And so it felt like a very dynamic, the ground was shifting out from underneath me a lot of times. And so that these compound requests in particular would go off and modify large parts of the system to the point of being very difficult to do a manual review and coming away with the confidence that it did the right thing. And so it's really that design, refactor, change behavior being 3 separate steps to something learned over time to get better results.
Do you ever find yourself saying please and thank you to the LLM as you were deep inside of your prompting?
Yeah, that's come up a little bit too, right? Where a simple thank you costs processing time, right? Like goes off and has to analyze that. So sometimes, and I think that's where the sentiment analysis was interesting, because in some cases I really did. It was like, thanks, that's great. Now I wanted to also do that over here. So it was, at least it wasn't, it was sort of a continuation of saying, hey, use the same requirements I used on this other thing that I like the results of, and let's go apply that somewhere else.
For me, it's my upbringing in the South. I can't shake it. I'm pleased and thank you to the LLM all the time. So much wasted power.
It is a pattern. And so I think what this comes into a little bit is like, if I was looking through my pattern in this type of development model, yeah, I could go out and I could run, a security scanning tool, a CLI, but it would still kind of be a separate step. And it was something I was probably not doing until much later. And similarly, because this was an open source project and there was sort of a, hey, I'm not sure this is entirely there yet, from a CI/CD process, that would be a good chance to get other people to review it or catch issues or run a scan at that time. But even then, that felt a little bit too late. So since using an MCP server, and this, everyone heard of MCP at this point, so I'm not going to introduce. I did a talk once at API World, and I felt it necessary to define what I meant by an API, but I didn't feel it necessary to define MCP because everyone had been talking about it so much. But then even within APIs, you might have some nuances of what you're talking about. But this continuous check in the loop suddenly became a little bit valuable, because especially in those compound requests that I was introducing regressions, something checking a little bit more frequently without me needing to remember to do that or say, oh, thank you for checking for me. It would become a little bit more helpful. So at the end of this, I started building out a web application, and I started thinking about, okay, well, my reputation is going to be on the line too, and that, yeah, there's a lot of people that have built and contributed to this, but if we release it and there's some problems with the web application, I better double check and make sure that we're following some of the best practices. So started thinking about, OWASP and other ways of sort of looking at the code that was generated and evaluating, did we do a good job? Could we have done something better? And so this is just sort of a shout out. A lot of organizations contributed data that led to the OWASP Top 10 in 2025. Semgrep, we were among those that submitted a lot of data, but we're also starting to look at some of that data for other reasons, right? Like, why did that list become the list that it was? And so, we took a look at data across 13,000 organizations, 340,000 repositories, so over 127 million security findings, and tried to say, like, hey, are there some patterns that are worth noting? And would some of those patterns help me if I'm building open source tools? So looking at the top 10, this is ordered by the percent of total in this data set. And the reason for that is just to sort of get a few interesting observations that might inform things that I might look for in an application or something that I'm working on. And so one of those is injection, right? So even though this is number 3 on the OWASP list, this is one that actually seemed to be occurring most frequently. And I think it's just, again, these are problems that have been out there: SQL injection, code command injection, cross-site scripting, yet it still is a large number. And I think one of the observations here is twofold. One is that if you make that mistake once, you have a good chance of having a lot of variance. So being able to go and look for all of the other instances, so it's not just one finding, but you're going to find a whole bunch of them. If it was something that was a particular input that was handling user input, chances are every one of those endpoints also has that problem. And then likewise, the fix rate, this number seemed a little bit low. And one of the thoughts was around organizational behavior of, do we fix these? Or maybe there's more context, like it's an internal application, or heck, maybe it's an open source application that we think everything's read-only. So maybe we don't have to fix that issue. And so there's a little bit of variation there in some of the data. Auth failures is another one that has a very high fix rate. This is a good example where if you're using a secret scanning tool, so like in the example of my application that I was building for the foundation, there wasn't a whole lot of case. We were deploying, had a deployment pipeline on Netlify, so there were some keys there, but even the public services that we were hitting were public services. So using a token to access it was not part of the requirements, but for applications that are using those types of things, the fix rate being so high makes a lot of sense that across a wide range of organizations, if there is an auth failure detected, the severity of that is probably going to get a little bit of attention. And then there are some other here, so like insecure design and looking at that, where SAST maybe wasn't being as effective at catching a lot of these examples because it just requires a little bit more context and intuition. So just like I was using LLM for generating code, it's a question of, hey, can I use this for doing an analysis? So maybe that's a good use case for AI detection capabilities, is some of the patterns here that you can't read the code. It's the absence of code that might be part of the reason. And I think vulnerable components, this one, at least in our data set, doesn't show up as much because there's a separate supply chain kind of detection process. But if you find a supply chain issue, if there's a vulnerable component, I'll talk a little bit more about that in a moment. It's kind of a thing that's sometimes easy to fix as long as it doesn't require substantial code changes. But in other cases, there might be another tool that's actually resulting in, well, we don't even use this dependency anymore, so get rid of it entirely. So that sort of brings us a little bit closer to this problem of supply chain. So New Year's resolution. After living through the last 6 or 7 months of lots of issues, so August 2025, Singularity. Has anyone heard about this issue? So this was the NX package. It was really interesting doing an analysis of this one. And I should note that a lot of these fall into the category of malware. So, so by window of exposure, we're talking about when is that malware introduced? When does it get pulled into a system? And then when can it be removed? And in many of these cases, the packages that were impacted were removed from the public registries. So hence there was really only a window of exposure, but there is a changing pattern here where the victim is a software developer. Right? So it's trying to use software developers who, in theory, have access to API keys to sensitive data systems. And if you can exploit that person's machine through installing some dependency in some package, you can get some of the credentials. And so some of these have been very interesting. So like Singularity, this was interesting because you would run NX, it would run a pre-installed script that would actually generate some code. And that code was designed to look for credentials on your local system. So from a fingerprinting perspective, it changed. Right? Like, so it's not necessarily like if you just look for one set of code, there's a little bit of non-determinism in terms of how that was created. So it also led to potentially not being detected in certain places. And then we had in September, Shai-Hulud. I remember the moment we were looking into this one in particular, and once we saw the name of the repository, everyone of course knows this now, but at the time was looking at it and it was sort of this aha moment of like, wait, isn't that, oh, that's from Dune. Oh, it's a worm, right? And it was just sort of suddenly that realization that, no, this is something that's actually replicating out, infecting more packages and trying to snowball into a bigger issue. Then it was Camo Link, Shai-Hulud. They upgraded the system and added some new features, including using secret scanning tools themselves on the developer's machine to try to identify secrets and exfiltrate them that way. React to Shell was maybe a little bit more of a traditional disclosure, but one that impacted such a large ecosystem. So in my case, it's felt maybe the React to Shell one wasn't too important because we weren't using React. But if you use a React Web Apps, which of course is one of the most popular, there were two incidents there, one a denial of service, another that sort of exposed a remote code execution opportunity. January, we've had VM2 was another discovery just recently in the way of getting breaking out of sandbox. NEN, they had an issue and so on. So limiting the window of exposure. So it's when that malicious dependency is introduced and until it's publicly known. And so from an incident response perspective, I spent a lot of time trying to, find these to really shrink that window of exposure. And I think this is actually a lot of these are success stories as opposed to failures, because a lot of these issues were discovered within a very short period of time. So unless someone was actively building, I think one of these that was trying to steal crypto wallets, for example, and it felt like such a big breach, but I think the end analysis was one person lost like $40 or something like that. So it was actually a success that not only was it detected, the news of it got out there, it made headlines, and then the registries responded, pulled away the packages so that no one else could be impacted. And so by removing them from the public registries, it also really limits that window of exposure in a way that really helps all of us across development teams prevent risk. So the other part of this, and so I think this is where there's a little bit of thought about this project, which is how do we continuously monitor supply chain? So there is this window of exposure of a malicious dependency and the time that it gets installed to the time it can be removed. And those grab headlines because they can do potentially significant damage. Someone might have to go rotate an API key. Someone might have a crypto wallet stolen or something like that. So there are some problems that come from that. But with that quick response from the community and the public registries, it really helps, kind of shrink that damage. But there's still sort of these boring regular security bugs to worry about, right? So while those were the headlines, there are lots of other dependencies, and including the applications we're building. So, so this just came out. So this is January 15th, but Svelte released patches for 5 new CVEs. So there's a couple of instances here where there's a denial of service. So one of the libraries, devalue, as far as parsing user-controlled input, was something that could be abused, resulting in effectively a denial of service of the application. There's another library, remote functions, had a similar type of problem. There was opportunities for cross-site scripting. So the hydratable had the ability for user input to be used in the keys of a hash to looking up some of the properties that might be rendered in a component. And then of course, allowing access to resources without auth. And so 2 of these were marked as high severity. So being able to have the supply chain tool to do that continuous monitoring becomes important, because this is not necessarily something that everyone is talking about. So there was at least a little bit of recognition of, oh yeah, remember the Singularity one, or remember Shai-Hulud, but this doesn't necessarily have a name. And this is important for the Svelte community, but just like React to Shell was important for the React community, that each of these ecosystems, they are open source projects, but they have their own susceptibility to problems. And in some cases like these, it's a security bug, so they're not going to remove necessarily the package from the registry entirely. Right? So it's still out there. It's just you shouldn't use that, and you should upgrade to where the patch is. And maybe that's a little bit of a different workflow from the malicious dependencies in terms of the length of time somebody is at risk. So what are some of the other findings? So I worked with some of the security researchers, and there was a project to evaluate some of the foundational models. What are the detection capabilities by going and looking at 11 real-world open source projects? And so inadvertently, the project I was working on for the DevRel Foundation could be one of these in someone else's data set. In this project, it was looking at the Python ecosystem. So it was 11 web applications, both front end and back end, that power various open source tools. We haven't actually, shared the names or anything like that, other than going through responsible disclosure types of things. But part of the goal of this was to go back to using LLMs to try to do an analysis, like how effective is this at finding problems in a web application? And so it was also a cross comparison of different models. So looking at one case for so Claude Code found 13 true positives, but reported 59 findings. OpenAI Codex didn't find any. And this is a pattern that actually held in a lot of different cases, that for certain classes. So the workflow for this was figure out a prompt that gives enough guardrails, enough focus to say, go and find this particular type of security vulnerability. Help me review a lot of code faster, at least giving me places to go. So instead of reading, like if someone's doing a manual code review, instead of trying to read every line of generated code, which would almost, if I'm using AI to generate that code, would be an enormous task. Then it becomes, hey, can we automate and pin down the things that we should go and maybe give a little extra inspection? And so that was the case here was, okay, this reported 59 findings, and then go manually one by one and check, is this actually something that should be addressed or not? And so I think that's where the true positives versus just the reported findings were coming out. And so we did definitely between different models see a variation, but also for different classes. So path traversal was a little bit different. OpenAI Codex was really effective at finding it. Found 8 true positives out of 17, whereas Claude Code found 5 out of 31. So in the Claude Code example, a lot more noise. Found a lot of things that it thought was a path traversal issue, but then sending a security researcher in to go take a peek at it, maybe not as much of a problem. And the other thing that this research sort of showed was sort of this repeated evaluation. So non-determinism was a factor. So looking at 3, 6, 11 findings for one particular prompt was across 3 runs, because we wanted to see, is this reproducible or not? So even running the same prompt on the same application multiple times, we were getting different sets of results. That could be a little bit alarming, but generally speaking, 445 different findings were manually inspected to try to come up with sort of an analysis of what this pattern was. And so that repeated evaluation was trying to give us a little bit more confidence of whether or not these were real issues, or whether this was a valid solution, or which model to use. And so what you might get from this is it's kind of a mixed bag. Yes.
Question about the for these true positives, were they originally used as training data to train these models? Do you think there might be a bias that make it easier to pick up those findings?
So that was taken into account. So these, that's the real worldness of these open source projects. So there are lots of benchmarks, repositories that deliberately have vulnerabilities. The assumption is, yes, some of those were used to train the models. And so it would be very easy to find the things that already had in its training set. And so all of the ones that were evaluated are under active development and changing. So, but in theory, there shouldn't have been any, which is why a lot of them were disclosed back to those applications about resolving them and providing some guidance. I'll pause here for a moment. So any questions about this one? So thinking about different security modes, sort of where it's coming from this application that was. So as far as SAST and SEA, identification of injection attacks was much more precise. comparing the AI detection approach versus just a rule-based engine. You could get more, depending on how much energy and effort. So 7 weeks, not a whole lot of time, shipping the application because the event date is not going to change, became important. Some of the other issues that came up, unsafe format string was caught. So of the code that I was generating, that happened quite a bit, which you can classify as logging failures. So of the code that was being generated, there were lots of places where user input would show up in logs, but the real risk of that for an open source project was maybe pretty low. But the supply chain dependencies was a big thing. And so being able to reliably know, hey, there's a new CDE, there's a feed of those, and those apply to the particular libraries that are in use becomes valuable. So from an SEA point of view, it's not just that, from a web application, a package file that lists all the dependencies. Because some of this was generated during the LM, not every package was used, or if something happened and we were changing the code, the LM was not necessarily going and cleaning things up necessarily, and it's less explicitly given instructions say, hey, go review all my dependencies and then go and clean up. That could have been a prompt, but that wasn't something that I had done, at least in the first pass. So having a tool that actually goes through and validates that in a reliable way is helpful for also checking those like Svelte CVEs. Did I use the devalue library? Well, it was included in the dependency, but did I actually call any of the methods or not? Or is it actually something that could be impacted through one of those issues? And so that really becomes that reachability problem. As far as AI detection, the IDOR identification became a really good example because even in Svelte, it wasn't the case in my application, but in many cases you might have middleware or a decorator, something that adds the authentication step. So suddenly you're not reviewing the code that's there, you're trying to find the code that should have been there that's missing. And AI detection is pretty good at intuiting that sort of thing. And then when it comes to this code review, then AI assistants can definitely help. So one of the things that was found in this application were path traversal issues. So this wasn't from AI detection, but from just a regular SAST scan. So path traversal issues were found, but having an AI assistant for interpreting those findings became helpful. So it correctly identified that it was an internal build script. So I mentioned one of the requirements was markdown files for authors to write blog posts related to the foundation projects. And so there was a little build script that goes through and tries to gather all the usernames and fetch some of the details from GitHub about who that author is and generate an author page. But that's run as a build step. So then it became the chances of a user actually, injecting some content into that would maliciously cause that build script to do something different, very unlikely. It would only be someone who's actually trying to build and deploy the application. And so, having an AI assistant goes through and tries to maybe give tips or suggestions around the context, I was impressed that it recognized that it was a build script as opposed to something that actually gets deployed and is running in public. So all that said, open source projects, what I hope the takeaway here is that by building this project for the DevRel Foundation, it really gave me an excuse or an opportunity to kind of go and experiment, try things out and use it as a vehicle for learning, both from doing a development project, but also then going back and analyzing it and trying to figure out what could have went wrong, what should I have done differently, what could I have done differently. But we can also go and look at other open source projects. I think that is something that came through with a lot of these security breaches, was actually looking at supply chain implications, and by going and looking at some of those open source projects and seeing, hey, what can I learn from this that I might be able to apply to production applications that maybe I'm using a day job that might be a private application, something that's not necessarily that open source, but more in nature. And this was mentioned before as well, but we do also support a lot of open source, including community editions. pre-tentative use. So some of the stuff that we do put out on our blog under open source or security research. There's a whole category where we cover a lot of these types of projects. This is me on LinkedIn as well. So if you want to connect, I do share a lot of this information about what we're doing at Semgrep, but also things that we observe in the industry in general. And if you are interested in the DevRel Foundation, there is a website as well. The one I was talking about is at devrel.org with a hyphen. And with that, some questions. I'll just